हरि करना।
Let's look into the few more models where we use conditional probability. So that's the first one out of this is, or we can say the fifth one is Navy Bayes classifier. Navy Bayes classifier. So this is a probabilistic model that makes predictions based on the conditional probability of a label given the features of an input. So, a Navy Bayes classifier is a probabilistic model that makes predictions based on the conditional probability of a label given the features of an input. So, in a Navy Bayes classifier, Navy Bayes is a classification algorithm that is based on Bayes theorem and the assumption of independence between features. So it calculates the conditional probability of a class given a set of features and selects the class with the highest probability. So Navy Bayes is commonly used for text classification, spam filtering, and sentiment analysis. So this is very important. So Navy Bayes classifier. So how it works is it calculates the conditional probability of a class. Let's take it as probability of class vertical bar a set of features. So whichever has the highest probability, whichever has the highest probability, whichever class has the highest probability with the respective features, and that one will be classified. So Navy Bayes is commonly used for text classification, spam filtering, spam filtering, and sentiment analysis. So what's next for us? Decision trees. Decision trees. So decision trees, these models use conditional probabilities to make decisions at node, each node based on the probability of a given outcome. Based on the probability of a given outcome. So decision trees are a type of supervised learning. Decision trees is obviously supervised learning algorithm that can be used for both classification and regression tasks, both. So the algorithm builds a tree-like model. It builds a tree-like model of decisions and their possible consequences based on the features of data. So at each decision point, the algorithm calculates the conditional probability of each possible outcome and selects the one with highest probability. Then it's hidden Markov models. We got the hidden Markov models. We say it HMMs. So these are statistical models that use conditional probabilities to model a system with unobserved states. So here in hidden Markov models are a type of statistical model that can be used to model sequential data such as speech, handwriting, handwriting, or biological sequences. So HMMs make use of conditional probabilities to model the probability of observing a sequences of outputs. Example, words, letters, amino acids. Given a sequence of hidden states that generated the outputs, HMMs are commonly used in speech recognition, handwriting, handwriting, handwriting recognition, and bioinformatics. And the next one that we have here is logistic regression. logistic that we have here is the logistic regression. So this logistic regression is also a probabilistic classification model that estimates the conditional probability of a binary outcome given the input features. Given the input features, again I'm repeating in the same way, conditional probability way. So this is a probabilistic classification model that estimates the conditional probability of a binary outcome, vertical bar, input features. So probability of a binary outcome given the input features. So logistic regression is a statistical model that's commonly used for binary classification problems. The model estimates the probability that a given data point belongs to a particular class, example 0 or 1, based on the values of its features. So, logistic regression makes use of conditional probabilities to estimate the probability of each class given the input features. Probability of each class given the input features. Then we have the last one, which is Markov chain Monte Carlo, MCMC. What we have is MCMC. So Markov models, these are used. Markov models are statistical models that use conditional probabilities predict predict the likelihood of a future event based on the current state. So MCMC methods are a class of algorithms used to generate samples from complex probability distributions. They are commonly used in Bayesian inference, where the goal is to estimate the posterior distribution of a set of parameters given some observed data. So MCMC methods make use of conditional probabilities to generate a sequence of samples that converge to the desired posterior distribution. So these are just a few. Conditional probability has a place. Conditional probability plays a crucial role in many machine learning applications, as it allows us to update our beliefs about a system as a new information becomes available. So overall, conditional probability is a fundamental concept in machine learning and is used in many different models and algorithms for various tasks such as classification, sequence labeling, clustering, and reinforcement learning. So, by and large, we have covered everything: classification, sequence labeling, clustering, and reinforce learning, other than regression. So these are just whatever we have seen so far. These are just a few examples of how different machine learning models can make use of conditional probability. In general, conditional probability is a fundamental concept in probability theory and has a wide range of applications in statistics, machine learning, and many other fields. So that's what these are the applications of conditional probability into various machine learning models.